Hello everyone. I hope you all are fine. I'm back again with a new research article that is Semantic Communications for Future Internet. In this topic, I'll tell you about the fundamentals, applications and the challenges of semantic communications for future internet that is 6G. Okay? So topics to be discussed in this video. We will discuss about the abstract. How does the idea of semantic communication came from? Secondly, we will discuss about the diagram representation of development of classical SemCom. I'll show you the diagram of development of classical SemCom. And what are the characteristics of classical SemCom? What is the bifurcation of classical SemCom? Next, we will discuss about the introduction of SemCom technology, and in the end, we will see the issues in 5G and how we can address the issues in 5G and overcome the issues in the future 6G technology. Okay, so number one topic is abstract. So you know as the years are going on, there is a rapidly increasing demand for intelligent services. Like this is the time for IoT, robotics, metaverse. So we need a sixth generation wireless network for that, and it is already in a very fast pace. So we are shifting from the traditional architecture that is 2G, 3G, 4G or 5G, and now we are going towards 6G. And the 6G, as we know, the traditional architecture network only focuses on the high transmission rate. But now we are moving forward to sixth generation wireless network. So we need metaverse or SemCom technology to move forward and to further innovate more applications by using 6G technology. So what do you mean by SemCom? We can see it as a revolutionary architecture because it is a kind of a revolution and it integrates user as well as application requirements. Like I want to play the game and I am at a physical place, but now I want to be in virtual reality. Like I can use the VR. So I can be present. I can play the game with another user who is also using the another computer, and he or she will also be present virtually, and we are virtually playing the game. So this is my requirement. So according to the requirements, according to the applications we need to generate, we can use semantic communication. So and the meaning of information into data processing and transmission, we can see the semantic communication, a new paradigm in 6G. It is a most important part in 6G. Next we are moving towards the SemCom technology. So several obstacles we need to overcome that is coming on our way towards 6G. So we need to build a smart wireless internet, that is SemCom enabled smart wireless internet. So for this we need to first overcome the obstacles, that is we need high data transmission rate, and we need low latency. Clear, the data processing should be less for the lesser time, so the latency should be less. But as you see, in case of 4G and 5G, the latency is very high. So we first see the motivations. How did the idea of SemCom and 6G came from, and the reasons for SemCom of using the SemCom semantic communication in 6G. So we provide a SemCom related theory development to you, and you will understand it very easily. So we introduce basically three types of SemCom. Number one is semantic oriented communication. Secondly, we will discuss goal oriented communication, and next we have semantic aware communication. So we organize the design of communication in three dimensions. Like we have three dimensions, and there are three types of communication system in three dimensions. Number one is semantic information extraction. We can say it SI, semantic information extraction. Then we have SI transmission and SI matrix. So for each dimension we require different techniques, and there are different kinds of benefits and limitations of each design of communication system in each dimension. Clear? And the challenges we will also discuss in each dimension. So we first introduce the potential applications of SemCom in 5G. There are so many applications like metaverse, AR, VR, IoT, robotics. We can use SemCom in 6G too, and these are the applications of SemCom. And in future also, we can see it in the future empowered applications, as we can use SemCom and we can innovate more project ideas by using SemCom and AR/VR technology. So there are research opportunities in SemCom in using SemCom and 6G. Okay, I hope you understood it. Next, we have the development of classical SemCom. This is the diagram of development of classical SemCom. You can see from the diagram we have classical SemCom theory is divided into two parts, that is goal-oriented communication theory and semantic information theory. Then the semantic information theory is divided into two subparts, semantic communication theory and strongly semantic information theory. So we need to first introduce a paradigm where communication is not an end. We can also introduce a third party system, as we can see it as a referee. Now we have to address the problems of uh, misunderstanding among different parties, like problem A, problem B, problem C, and we need to address these problems. We need to sort out these problems. Clear? Then we can generate a generic model of semantic communication. We have to define the notions of semantic noise, and we have to create the channel. So there will be noise, there will be distractions, there will be there will be so much challenges, you can say. So you have to define these notions in your project. Clear? You have to derive the semantic capacity of the channel that you have decided. Then you have to define an ideal language model for that. You have to introduce the concepts of state descriptor and the range. Then you have to define the amount of information contained by the sentence. So these are the semantic information theory. This is the required development of semantic communication theory. I hope you understood it. Then we have introduction of semantic communication in future technologies. So number one is the motivation. We will see how did the idea of semantic communication came from. So as we revisit the development path, like we have seen the technology from first generation 1G to 5G communications, and it has been seen that it is optimized, that the data your 5G, 1G, 2G, 3G, these are only the data oriented performance metrics, such as they are basically based on communication data rate and bit error probability, and they are ignoring the service goal related metrics. Okay, they are only focused on the performance. Okay, so in 6G we will overcome these challenges. We will be more helpful, we will be more human centric as compared to 1G, 2G, 3G or 5G, you can say. So you know that the 3G only focused on mobile broadband development, and it is evident that it promised 1,000 times data rate of 2G, means the data rate in 3G is much higher as compared to 2G. But as you compare 3G with 4G, the data streaming is very high, and it is about 1,000 times the data rate of 3G. So the 6G will be more than the 5G. So you can also say that the Shannon first demonstrated that there is possible in noisy channels in the classical CIT literature. Okay, classical CIT is classical information theory, and he believed that the semantic communication are irrelevant to the engineering problem. We need not to introduce semantic communication in engineering. Okay, But as the technology progressed with CIT, the 5G introduced, and it was the breakthrough, as we have different types of services from digital twins. You have seen digital twins, edge computing, fog computing, IoT, Internet of Things, robotics. Now we are using Internet of Things. We have connected our mobile phones, our laptops with only one device, and we have used sensors to that, microcontrollers, and we can say it as Internet of Things. We have connected so many devices for that. So this is the advent of technology, and through the supporting technologies we have URLCC, that is ultra reliable low latency communications, and MMTC, that is massive machine type communication, and it has enhanced mobile broadband EMBB communication. I hope you understood it. Then we have the content centric. The from 1G to 5G, the content was only the data is only the content centric. Like, it doesn't have the high quality of experience that is provided to the users, but user only wanted high quality of experience. Although the data is provided, content is provided to the users, but the quality of experience is very less. So this barrier, this you can say this limitation is overcome by 6G, and the 6G will be human centric, data and resource intensive. So one such application, this is the most important application of 6G and SemCom, that is metaverse, and it is the base of AR or VR. You have seen in engineering colleges AR VR labs, that is augmented reality labs. You have seen, if you have been through, and VR virtual reality labs. So what is the benefit of these labs? Okay, what do you mean by metaverse? So you have seen the metaverse is the future internet. So as we navigate, as we go through the web pages of internet, now we will explore the virtual worlds of metaverse. Like, I am sitting in my room and I'm playing a game with someone who is another user. Okay, and we both are playing the game, clear, and we are physically present in different at different places. And if we play the game through metaverse, then it means that we are physically present in front of each other, and I can see through my glasses that both of us are playing the game opposite to each other, as we are not opposite to each other in physically. As we can say, we are not in front of each other, but we will be in front of each other by using metaverse and sunglasses, that is through with the help of 6G. So it is in the high demand. So we will soon explore the virtual worlds of metaverse through a head mounted display and AR VR glasses. As I told you, you can see this video through more YouTube videos, and I will also share these videos. The metaverse is formed via the synchronization of virtual and physical worlds. That means physically, I am physically present here and I am connecting virtually to someone else. That means this is the metaverse, is the synchronization of physical world and the virtual world, and you can see the result of one's action in the virtual and physical domains will be linked. Like, we both are playing the game, and in virtual reality we can see both of us playing the game. Okay, then we have seen AI, artificial intelligence, edge intelligence, virtual and augmented reality, blockchain technology. These are the quality of experience metrics required for the users, and this is the most important technology required for the successful implementation of metaverse calls. Okay, and the massive data from new applications increases, as you know, significantly. The processing latency of conventional communication networks also increases. Okay, data is also increased and the processing latency will also be increased. So there will be some difficulties in 6G networks which we need to address. So what are these difficulties? Number one is the emergence of new services. That is, if we want to use a metaverse, if we want to use AI, edge intelligence, then we require 6G network to support, because it requires high volume of data, and high volume of data can also be shared only with the help of 6G. Next we have Secondly, D2, 6G applications require a large number of nodes. That means a large number of collaborative robots that will help each other, and hyper intelligent IoT is required. Which requires fast system responses and reliable, effective information interaction. That means it requires a massive number of nodes. This is the limitation, and we need to overcome it. So more number of networks we need to consume, because we need to update the information on real time, and every second we need to we need to update the information. So more number of network resources, we need more number of users, we need more number of laptops, and the data is very massive, so we need network resources for that. So in response, semantic communications is inspired as a brand new technology in 6G. It is the highly required technology. So we can see the capacity of system 3G, 4G, and the data oriented communication, you can say 1G to 5G, is improved only at the cost of system complexity. But SemCom enables all communication participants to like I am the participant, and my burden of data is very high. So the SemCom helps to transmit the data to the receivers, only the data which is relevant. Okay, it transmits only the relevant data, and it transmits the data after pre-processing of data, and it uses AI technology for that. Firstly, I have a file, I have used 5G, so there will be no SemCom and all the data is transmitted. But if I am using 6G, if I have used SemCom technology, then it pre-processes the data and it filter out the irrelevant information. It only passes the relevant information to the receiver, okay, by using AI technology. So the development of both SemCom and 6G are mutually reinforcing, mutually coordinating with each other, and it will bring solutions to the three difficulties, that is D1, D2, D3 we have discussed. It will bring solutions for that. And on one hand, we can say the availability as well as connectivity of distributed computations and the ubiquitous, the AI networks are present everywhere in 6G. They will allow SemCom to be deployed at very large scale. And on other hand, we can say it overcomes the traditional communication limitations or the constraints, and it will help in improving the network performance, which has not done ever before. And the successful training and development of SemCom example, we can see the low latency. The data processing rate is very less in 5G, and hence reliability, it can be fully realized. That is, what are the visions of 6G? Lower latency than 5G. That means in 5G, the latency, the data processing time rate is very high, and in 6G, the data processing rate should be low, and the reliability should be higher as compared to 5G. These things should be fully realized, and the SemCom has to address the three abilities D1, D2, D3, as we have discussed before. So, so we need to reduce the wireless data transmission burden of 6G network by using the SemCom. That's why we are using SemCom, and we need to enhance the efficiency of 6G network control, plus use the semantics of information to design effective network resource allocation schemes. So these SemCom and 6G, the collaboration of both of them have attracted the attention of a research community as well. There are so many researchers, but there is not even a single research paper that could give the complete overview of the developments and the challenges or future trends of SemCom enabled 6G. So it is very difficult right now. Researchers are doing work, and they will formulate a strategy, and they will formulate some new developments or challenges or future trends. It will come year after year, okay? But you have to know about the base of 6G and semantics communication. If you are not wary of the base, you will not do further innovation or research in this. So this is the very new topic. This is very important topic, and the survey, this survey aims to serve as a useful. Like I am sharing the data with you, so it would be, I hope it would be useful for you. It would guide you for future studies to do research, or if you want to use the SemComs in your research work, project work, you can incorporate SemCom projects into the future communication architectures too. So this is enough for today. We have done, and stay tuned to my YouTube channel. I will be back with some more videos on this topic, semantic communications. I will be back with the fundamental challenges and much more. Till then, bye. Have a nice day. Thank you.